Now we're going to take a look at determining the order of a reaction with respect to the reaction rate. Basically what we're going to do is look at the dependence on the reaction rate on each of the reactants presented in a problem. In this reaction we have nitrogen monoxide reacting with chlorine gas to make a product. So what we can do is we can manipulate the concentration of each reactant while holding the other one constant. When we do that, we can isolate the impact of that reactant on the overall reaction rate. Now the orders can either be 0th order, which indicates that there is no impact on the reaction rate as a result of that reactant concentration. It can be 1st order, which shows a linear effect, meaning that, or equivalent effect, whereas if you double the concentration, you double the reactant rate. Or it could be 2nd order of reaction, indicating a squared impact, where if you double the reactant concentration, you will quadruple the rate. So we'll take a look at this and determine what the order is with respect to each of the reactants, and then the overall order of the reaction, which is going to be the sum of the orders of each reactant. So the first one, let's just look at the first two trials here. We hold the concentration of nitrogen monoxide constant, and we double the concentration of chlorine. And you can see that the rate doubles as you double the concentration. So for Cl2, when you double the concentration while holding the other reactant constant, we double the rate. This would be a 1st order reaction with respect to Cl2. Then, trying to isolate the nitrogen monoxide's impact, we look at two trials where you hold the concentration of chlorine gas constant. So we'd have the 2nd and 3rd trial, where that's the same. So now we can look at the impact of doubling the concentration of nitrogen monoxide. So, when we double the concentration of NO, your rate actually gets quadrupled. Keep in mind this is 10 to the negative 5th, so that's really like 11.4, which is 4 times the reaction rate before it was doubled. So we can say that the order with respect to nitrogen monoxide would be 2. And when we write the rate expression, it's equal to some constant that we'll determine in the next video times NO to the 2nd and Cl2 to the 1st. So the overall order of the reaction would be the sum of those orders, so you would get 3 for the overall order of reaction. Right. Now I want to just remind you that these orders have to be determined experimentally. They cannot be determined just by looking at the stoichiometric coefficients from the overall reaction.